This isn't a casual question, it's the Fermi Paradox, and it has a terrifying implication. The great silence of the universe might be a sign that intelligent life is incredibly rare, or it could be a sign that the survivors have learned one critical lesson. It is suicide to announce your presence. So what happens if we finally make contact? If a signal reaches us or a probe arrives in our solar system? The movies have given us two options: a fleet of benevolent teachers or an armada of hostile invaders. But the reality is likely to be far more complex and far more dangerous. To understand what would really happen, we don't need fiction. We need three powerful real-world tools. First, the Kardashev scale to understand the physics of power. Second, game theory to understand the logic of survival. And third, our own human history to understand the grim precedent of contact. These tools will help us answer the two questions that truly matter. In a conflict, who would win? And is conflict the most logical outcome? Let's start with the first question. Who wins in a fight? This isn't a question of strategy or willpower. It's a question of pure physics. In 1964, astrophysicist Nikolai Kardashev proposed a scale to measure a civilization's technological advancement based on the energy it could command. A Type 1 civilization can harness all the energy available on its planet. Roughly 10 to the 16th watts. We aren't there yet. Right now, humanity is about a Type 0.7. A Type 2 civilization can harness the total energy of its home star, about 10 to the 26th watts, 1 billion times more powerful than a Type 1. A Type 3 can command the energy of its entire galaxy. Its power would be godlike, completely beyond our comprehension. Now consider this. Any civilization with the technology to travel between the stars, to cross the vast emptiness of space, would, by necessity, have solved immense energy challenges. They would be, at minimum, a high-end Type 1, and more likely a Type 2 civilization. So who wins? The answer is brutally simple. They do. A civilization that can harness the energy of a star could boil our oceans from light years away as a trivial act. For them, a conflict with us wouldn't be a war, it would be pest control. The power gap is so immense that our survival would depend entirely on their intentions. This leads us to the more important question. Knowing they could destroy us, would they? This becomes a problem of strategy. In game theory, there's a famous thought experiment called the prisoner's dilemma. Two players can't communicate. If they both cooperate, they both get a decent outcome. But if one betrays the other, the betrayer gets a huge reward, and the betrayed gets a terrible penalty. If both betray, the outcome is awful for both. Now, imagine this dilemma with extinction on the line. You cannot communicate clearly across the gulf of space and biology. You do not know their motives. They do not know yours. The most brutally logical, self-preserving choice is often to betray, to eliminate the potential threat before it can eliminate you. This concept is the basis for the dark forest theory, a chilling solution to the Fermi Paradox. The universe is a dark forest, teeming with silent hunters. The only way to survive is to stay quiet, because any sound you make could draw a predator. In this model, the first act of contact is to pull the trigger, because the risk of a peaceful competitor eventually becoming a threat is too great to take. If this sounds cynical, we only need to look at our own history. We have a factual blueprint for what happens when a technologically advanced culture meets a less advanced one. When European explorers arrived in the Americas, the outcome was not an equal partnership. The drivers were almost always resource acquisition, territorial expansion, and a sense of inherent superiority. But even without malicious intent, the result was catastrophic. The most devastating impact came from something the colonists didn't even consider a weapon: disease. Microbes to which the native population had no immunity caused a demographic collapse. Why would we assume first contact on a galactic scale would be any different? An alien biology could carry microorganisms that are harmless to them, but apocalyptic for life on Earth. In this scenario, their very presence, no matter how peaceful, would be an extinction event. So, when we combine these frameworks, a sobering picture emerges. The power disparity is absolute. The strategic logic points toward paranoia. And our own history provides a grim precedent. This leads us to the most realistic conclusion. A civilization intelligent enough to cross the stars would also be intelligent enough to understand all of this. They would be masters of physics, strategy, and likely history. They would calculate the immense risk of revealing themselves to a developing, unpredictable, and tribal species like humanity. And they would arrive at the most logical, self-preserving action. It is not to attack. It is not to say hello. It is to stay hidden, to delete the message, to remain silent. The greatest sign of intelligence in the universe might not be a radio signal. It might be its absence. In the end, the question isn't, what will aliens do to us? It's, are we a species that another would take the risk to meet? Our own struggles with conflict, our tribalism, our stewardship of our own planet. The challenge of first contact, then, begins at home.